Hello everyone, welcome to another video. This is part 7 of my Gateway API for AKS series, and today I want to show you how we can combine everything we did so far and deploy a pull request into a new namespace and also reuse our TLS certificates and have a completely new fresh environment for testing. The plan for today is first I'm going to show you a quick overview of the architecture, what we've built so far. And then I'm going to show you the pull request demo and also how I configure the pull request to be able to do what I will do. First off, for the architecture, what we did so far was we created a Kubernetes cluster. In my case, I used AKS. Then I installed the application gateway for container. This will take care of, for example, the TLS termination. Then we have a resource inside the Kubernetes cluster, the gateway. This gateway provides a hostname where we'll point our DNS to, and it also has a couple listeners. So for example, it's listening for our domain. After this, we have a couple HTTP routes. These routes configure how we route our traffic from the gateway to the applications. So in this case, we have one route how we can get our request to the service A, or in the end to the pod of application A, as well as the one for B. Additionally, we installed the Cert-Manager and also the cluster issuer, and these two components create TLS certificates from Let's Encrypt. Once it's set up, it can be done completely automatically, and we can use it for specific domains as well as for wildcards. So as I just said, I'm going to reuse all the components I have created in the previous videos. So if you're interested, I will link you the playlist in the description down below so you can go through it step by step. I will also provide you a link to all the demos I have so you can just copy paste and follow all my videos. In the last two videos, I created the Cert-Manager and the cluster issue. We also configured them. This means we are able to create specific TLS certificates, but I've also integrated them with my Azure DNS zone, and this allows me to use wildcard certificates. The reason why I have to do this is for security purposes and the way how Let's Encrypt checks if I'm the owner of this DNS. After the demo, I'm also going to show you the gateway configuration and the host name. This is important because I have configured my DNS to point to the host name. This means I have a CNAME record for my URL, and through this CNAME record, I'm able to get my request to the gateway and then to the pods of the application. So next I'm going to show you the pull request demo in Azure DevOps, but it will work in no matter what tool you're using. So I also have a couple demo pipelines, but I kept them as simple and as general as possible, so you can just copy paste them probably. With this said, now let's switch over to Azure DevOps, and then I will show you how what happens when I do the pull request, and afterwards I will show you how I configured everything. All right, here in Azure DevOps, what I'm going to do now is I make an update to my code just to simulate that I've implemented a feature, and then I will create a pull request. So I've already prepared my folder with my demo pipelines. So it is the same name as the title of this video. And here you can see we have a file, and I'm just going to delete this file. So if I try to delete this file, I have to obviously make a new commit to the main branch. If I try to do this, I will get an error message. This is because I configured my main branch that I can only commit through a pull request. This is something best practice for many years, so I hope you already have this in place to protect the main branch. If not, I'm going to show you later how you can set it up in Azure DevOps. This means since I can't commit to the main branch, I have to create a feature branch. I like to name my feature branches feature. If I'm working on a bug, I name them bug. Then with the slash, I put them all into one folder so I can group them together. And in this case, I give it the name delete file. Then I commit I add my commit message, and in Azure DevOps, I can already create a pull request. So for you as a developer, you would obviously use your IDE, for example, Visual Studio Code. That would also create a new branch, commit to this branch, and then push this branch. So let's commit to this branch. Now let's say we're done implementing our new feature. Now we can create the pull request. So on the left side, we have here in the menu pull request. Also, if you use Visual Studio, it will suggest to you to create a pull request. Then you will also end up on this page. Here, Azure DevOps already sees that we just have updated the branch called feature delete file, and it already suggests that we create a pull request. Otherwise, you can create a pull request down there. Then you just have to add the branch yourself. Here it also adds the title automatically. In this case, it's just a commit message. I provide a title that is usually the same as the ticket name. Now I don't have a ticket or work item. So let's just say delete unused files or file. Then we have the description, and then we can already create the pull request. So nothing special about this. What's interesting now is this first line. It says pull request deployment CI build queued. So this pull request deployment CI is the name of my build pipeline. And I've configured my pull request to every time I commit to the folder of this video, this means the folder with the name part 7, I will run this pipeline. This approach allows me to have different pipelines for different folders. For example, if you have the monorepo approach and I have 3 applications, application A, B, and C, then I want to run different pipelines depending on what application I build. And with this, you can distinguish how and what you build. I will show you after the build is finished how I set it up. But for now, let's take a look at the pipelines and let's see what is happening there. So let me find my folder. Here I have 2 pipelines. We can already see that the first pipeline, the CI pipeline, is already finished, and this automatically triggered the CD pipeline. So here in the CI pipeline, I just, as you can see, tested a lot in the past, but I kept this pipeline as simple and as generic as possible. So all I do here is I have a bash script that says building great stuff. Usually in a real world project, you have here the build, unit tests, building Docker container, so everything you need to build your application. If you're using Helm, you might also create a Helm chart, and then in the next step in the deployment pipeline, we can reuse this Helm chart. So now let's take a look at the deployment. Here we can see I have 4 stages, and sometimes the first 2 stages run like here, and sometimes only the 3rd and the 4th stage runs. This is because I distinguish if it's a pull request or if it's a normal deployment. So what we can see down here is the deployment for the test and the production environment. This means after I've merged to my main branch, I automatically deploy in these 2 environments. And up here, this is the pull request deployment. So the first one, the green one, is the deployment itself. And the second one is the cleanup stage. This stage is necessary because once I'm done testing, I want to delete everything and don't want to have the resources being used. But I have to wait until someone reviews it and approves the pipeline. Otherwise, I would create it and then delete it immediately. Therefore, we have this blue symbol, and this means it's waiting for a reviewer to approve. If you take now a look at the pipeline, we can see here this one approval is needed and this stage is waiting. But now let's take a look at the pipeline itself. And here again, I have the wrong branch selected. I have made this pipeline as generic as possible because every team uses a different approach. You might be using GitOps, you might be using Helm, maybe some YAML files, maybe something completely different. There's so many approaches, so I just have a simple demo application using YAML files, and I've also split it out so we can see one file after the other. What's probably the most interesting for the deployment is the top part here. So I don't have a trigger set, but it still started automatically. This is because I have here the reference to my CI pipeline. And also I include these branches. So if I have commits on the master or main branch, but also on the pull or refs pull branch. I have these two branches because in the past, Azure DevOps used, I think, the refs/pull branch, and nowadays it uses the pull branch only when we have a pull request. I'm not entirely sure, but I just kept it in case somebody is using an older version, so it should work. If you're using GitHub or GitLab, then you would have to look up what the name of your branch is there. Next up, I'm defining a couple variables. So this is just the general information about my Kubernetes cluster, the service connection, so I can access my AKS cluster, my URL. So in this case, you can see it's demo.pullrequest.programmingwithwolfgang.com. This reminds me that I forgot to change this. I used this for testing, but then I changed my DNS, so it's only pull request. So I have to update this. I save it, I commit it to my feature branch, and then save it. Now the build runs again, and then it deploys again. So it will take a couple minutes, but while the new pull request version is being deployed, let's take a look at how it's done. We have the stages. These are the 4 dots we have seen before. To be more specific, inside the stages, we have one stage for each dot. So we have the pull request, we have the delete of the pull request, we have our test environment, and we have the production environment. Here in the deploy pull request, I have this condition, and with this condition, I say that it should only run if the source branch is from a pull request. If it's not from a pull request, for example, after the pull request is finished and I committed to the main branch, this stage will be skipped. The first step I have here is a PowerShell script, and in this PowerShell script I get the ID of the pull request. This is how I distinguish between deployments. Every pull request deployment gets its own ID, and therefore I can have a unique URL, and I can also have a unique namespace. So I name it PR for pull request dash the ID. So if a colleague of mine creates a pull request themselves, he or she will have a different ID, and therefore it won't interfere with my deployment. Here I have to admit, I searched for this regex a couple years ago, it worked, and since then I'm just copy pasting it. I can't fully explain how it works, but I'm sure some of you know how it works, and for the rest of us, just copy paste it every time you need it, and it will also work. In the next task, I'm connecting to my AKS cluster. I need this because I have to download the credentials of my cluster, and this will allow me to connect to the cluster using kubectl. If you have a different deployment approach, for example, if you use Helm charts, GitOps, then you might be able to use built-in tasks. But again, I wanted to keep it as generic as possible, and therefore I just get the credentials. In the next task, I'm creating a new namespace, and here you can see I have the variable namespace. So if we scroll back up and take a look at this variable, I can see here, this is what I said before. It's PR dash and then the ID of the pull request. What I also do is here I've commented out just to create the namespace, because if you deploy the pull request again, like I did, because I forgot something, I changed something, deployed again, then it will fail because the namespace already exists. So a better version would be this command here. It checks if the namespace already exists. If it already exists, it will just skip this step. If it doesn't exist, it will create the namespace. Next up, I'm deploying a new deployment up here. And here again, I keep it as simple as possible. So I just deploy a dummy application, and this will allow me to see something when I call the URL at the end. This is just a basic traffic who am I on port 80 with one replica. But for your applications, you might have here your Helm chart deployment, or however you deploy your application. In the next task, I do basically the same, except that this time I deploy the service. What's important here, I use the cluster IP because I want to access my service and my pods through the gateway. I don't want to access it directly. Down here we can see it's just port 80. So I listen on port 80. I also send the request on port 80. But when I test it, I use port 443 for HTTPS. But it only reaches the gateway with HTTPS. And from then on, it's going to be HTTP. The next task is our HTTP route. This will tell the gateway where it should send the request. So if I use my URL, the pull request.programmingwithwolfgang.com, I land at the gateway, and this HTTP route tells the gateway to which service it should send my request. It works because I have here under the host names my URL. Down here I have the backend where I should send it to. In this case, the one I just deployed. And up here I have the reference for the gateway. So this is the gateway I've created and the namespace it is in. If you don't know how this works, I would highly encourage you to take a look at my previous videos, because there I set up everything step by step and also go more into the details how it works. For now, let's continue, and we have one last step, and this is just an informational step. Here I print the URL where the testers can access the new environment. This is especially useful for non-technical people. If you have marketing manager, QA manager, maybe your management in general, they can just see the URL, or you can send it to them, and then they can access it the same way as the test and the prod environment. We also have here the delete step, but for now, let's take a look at the pipeline, because it should have redeployed the application. Then we're going to take a look at the application. Let's say we test it, and if you are happy, we can start the delete process. So if we go back here to our pipeline, we can see here it has been deployed. If we open it, we can go to the stage, and here we can see all our steps. So for example, it got the pull request ID. In this case, it's 31. Down here we see the URL, and here you can see it's PR-31 because it's a unique ID. So pull request.programmingwithwolfgang.com. If you open this, then we should see our application running. We should see HTTPS. This means we have a valid TLS certificate and everything should work. So let's click on it and let's see if it's actually true what I'm telling you here. Here we can see it is running. We have our URL, the PR-31. We have a valid connection. The connection is secure. If we click on it, we have a valid certificate. If we click on this, we can see that the certificate was issued to the wildcard.pullrequest.programmingwithwolfgang.com. That's what we have configured in the last video. And now I'm just reusing this because I add something in the front, the PR-31, so I can reuse the certificate. This means developers don't have to care about certificates. They can just use it. They actually don't even have to configure to use it. They just say, I have an HTTPS connection. And the gateway and the Cert-Manager, everything in combination will take care of it. This means the infrastructure team, if you have one, sets this up once, and then the developers can just use it. So from a developer perspective, I think this is amazing. Now let's say we have reviewed the deployment, we are happy how it is, so we can now delete everything we have deployed and clean up the resources we have been using. To do this, we go to our pipeline. Here you can see we need the approval. Then I can click on review. Here you can configure different approaches for the reviewal. In this case, it's just one person. You could also add an entire group. You can say I need multiple people. So it's quite great how you can do it in Azure DevOps. In GitHub, GitLab, all the other tools, it might work a little bit different, but in general, they're quite similar. So in this case, I'm happy with it. So I approve this. And in a couple seconds, we'll see that the next stage will run. While the agent is starting for the stage, let's take a look at what's happening inside the stage. So we go to the edit page again. We select our feature branch. If we scroll down to the stages, we can see we have here our pull request deployment, and here we have the delete. So here I have this depends on and the condition that I only run the delete if the deployment succeeded. Since I only run this when the deployment succeeded, I also don't have to check for the branch because the deployment only runs on a pull request branch. Therefore, the delete will only run on a pull request branch. Then as a first step, again, I'm getting the ID of the pull request. This is so I know what namespace I have to delete. In theory, you could also just reuse the variable, but again, I wanted to keep it as simple as possible. And a real-world pipeline would probably look completely different because you would optimize everything, but it's very hard for you as a beginner to get started with it. Then we already have our last step. So here again, do an easy AKS get credentials. This will allow me to access my Kubernetes cluster using kubectl. And then I use in the same task, because I just didn't want to create a new one, the kubectl delete namespace. And this will delete the namespace. Since we have deployed everything inside this namespace, everything we have deployed will be gone. If you have a bigger environment and maybe you have also set up some Azure resources like a database, a service bus, a storage account, then you would also have here more steps down here where you also delete them. But the goal of this stage is to delete everything you have created before. So if we now go back to our pipeline, it should be already finished. And here you can see we have now the 2 green dots. So this means we have deployed and we have deleted again. This means I can now go back to my pull request. And in theory, we could already finish it. So here you can see we have one optional check that failed. In this case, it's optional and I must link a work item. Usually I set this to required, but since I was too lazy to create one, I have set it to optional. My opinion is that I can't do any work without work item. Therefore, I usually configure it to be required. Additionally, I've configured if there's a pull request, if there's a comment in the pull request, then I can't finish my pull request. So now it's blocked. I do this because I want everyone to be happy. So if a colleague says, I did something wrong, he doesn't like something, I want to talk about it. So here I can write my comment. This also helps as a documentation, because if I go back in the future and I see why we did this, maybe we talked about it, so I can write something back and then I can resolve the comment. I have usually the policy that the person who created the comment resolves it if they are happy, but it depends on how your team does it. But now let's say everyone is happy. I also had somebody else approve my pull request. Since I only have one user, I approve it myself, but usually somebody else has to approve it. And now I can complete my pull request. So here I like to configure that I complete the work items. In this case, I don't have one, so nothing's going to happen. I'm going to automatically delete my feature branch. And we could also update or customize the merge commit message. Here I have usually the title of the ticket already. And here I have the ID of the pull request. So it might be in some teams that we delete this. So I see the pull request ID. This means it's very easy for me to find in what pull request this was done. And I also have the title here of the ticket. So therefore, it's very easy to find the ticket and I see the explanation what we want to do. Additionally, the merge type, I usually set it or only allow squash commits. So in this case, I can only select squash commits. Then I can merge it. Now it's merging my changes to the main branch. And if we go back to the pipelines now, we see the pipeline is running again. This pipeline is running because I made changes to the main branch. Therefore, it's triggered automatically. Once the build is finished, then the deployment branch will be triggered again. And this time the deployment will go to our test environment. Here again, it totally depends on your environment, your team. I see many teams that like to trigger it manually, maybe at the end of a sprint, but in theory, you can do it fully automated. But this also means that your team has to be mature enough that you have everything tested and that you have to trust everything will work. So here we can see the deployment pipeline has been triggered. And we can also see that first two stages are being skipped because it's not a pull request and the test deployment is running now. So here it takes 5 seconds because I think I don't have anything inside this deployment, the same as for the prod. So now let's just say everything worked and we deployed our new changes. All right, this was everything I want to show you about the pull request demo, what we can do. And now let's take a look at how we can configure it in Azure DevOps. So the first thing is we have to define pull request policies. We can do this under the project settings. Then we have repositories. Then we select our repository. In this case, I only have this one. Then we go to policies, we scroll down and we select our main branch. So it's quite hidden to get there. And here I can configure everything I want. So for example, what happens when something is changed and how many reviewers do I need? In this case, I configured I need 1 reviewer. I can approve it myself because it's only me. And every time there are changes, I want to reset the votes. I like this because if somebody approves it, they say they are fine with it, then I make new changes and push them. I want them to check again because I could mess up something they didn't see before. Next, I have the check for linked work items. And as I said, I have it here optional because I was too lazy to create one. In my real world project, I've set this to required. Then I always check for the comment resolution because if there's a comment, I want it to be resolved, that everyone on the team is happy. Here we can limit the merge types. As we have seen before, I set it to squash merge. I like the squash, but here you can configure whatever your team should use. And you can also give 2 options if you want. Now the developer can decide which one they want to use. The most interesting part is probably down here, the build validation. Here we can configure what pipeline should be triggered and when. So if you open this, we can see here the pipeline. So in the list, you can select all the pipelines you have. So for me, it's the pull request deployment CI pipeline. Then you can configure when this pipeline should be run. Since I'm using a mono repo, this means I have all my applications inside one repo. I want to run the pull request pipeline when I change something in the pull request folder. This is what this line does here. So if anything changes inside this folder, run this pipeline up here. That's triggered automatically. It has to be valid. So for example, if some unit tests fail, I won't be able to merge my pull request. Down here, if the pipeline is too old, I have to rerun it. Then I click Save and I have it configured. Also, as soon as you activate just one of the settings here, so let's just say I activate only this one up here. Now I'm already not able to commit directly to the main branch. So there's no on-off switch for it. It's just as soon as something is configured, the main branch is protected. This is already everything we have to configure for the pull requests in Azure DevOps. I'm pretty sure in GitHub and GitLab it works similar. Especially in GitLab, I think you don't have as many options to configure. But if you're using these tools, just take a look, and then you can also protect your main branches, and then you should be able to do the build validation. As a last step, I want to show you the gateway, the hostname on the gateway, and then my DNS configuration. So this is something I've already done in the last videos, just in case you haven't seen it, so you have an overview of everything I've configured. So let's switch over to the terminal and let's take a look at that. Here in the terminal, I'm going to define just two variables. That's the namespace where I have deployed my gateway and the name of the gateway. And with this, I can do a kubectl get gateway with the name and the namespace, and I paste it as a YAML. Now we have the entire YAML of the gateway. If we scroll up a bit, then we can see the configuration. If I can find it. Here we have our HTTPS listener, and as you can see, it listens to multiple host names. So it's actually starting here. So the first one is listening to traffic. Then I have a reference to the secret of the traffic. The secret contains the certificate. Here I have the URL for my Nginx. If we scroll a bit further down, here I have the host name for the wildcard.pullrequest.programmingwithwolfgang.com. We have also here the reference for the secret. And when we deployed a new application like the PR-31.pullrequest.programmingwithwolfgang.com, it uses this secret or this certificate. Therefore, we are able to use an HTTPS connection without creating the certificate ourselves. A little bit further down, we can also see here the host name. So this starts with GKG. And the host name is great because back in the days with Ingress, we had an IP address, but now we have a host name. This means we can use a CNAME record and point it to this host name. In the next step, I'm going to show you in the Azure portal that this host name, the wildcard.pullrequest.programmingwithwolfgang.com, has a CNAME record to point to this hostname value. So let's switch over to the Azure portal where I have my Azure DNS zone, and I'll show you what I've configured there. Here in the Azure portal, in the Azure DNS zone, I've already filtered for the host name. This means we see only records that are pointing to this host name. If we scroll down a bit now, we can see here we have this wildcard.pullRequest. This is pointing to the host name, and therefore I'm able to access my AKS cluster with the PR-31.pullRequest.programmingwithwolfgang.com. Again, everything you've seen today, I have set up in the previous videos step by step. So if you're interested in any of the topics, you'll find the playlist down below where you can see how I set it up. This is everything I wanted to show you today. So today we have seen that we can combine everything we set up so far. This means the Cert-Manager and the cluster issuer, as well as our gateway and DNS configuration, and we reuse this to deploy our pull request. Thanks to the wildcard certificate, we were able to use HTTPS connections without having to configure anything. Also, since the DNS was configured with the wildcard, we also didn't have to configure anything during the pull request for the DNS, and we could just create our new unique URL. A couple of videos ago I said the next videos are going to be super interesting and exciting, so I hope for you setting up the Cert-Manager, the cluster issuer, automating the certificates, now automating the pull request deployment was for you as exciting as for me. For me, this is what makes engineering amazing. Like, we can automate stuff, it makes our life in the future way easier. It's exciting to figure out how it works. So I hope you share my excitement. If you have any questions, any comments, please let me know in the comments down below. Also, I would appreciate if you could like the video, and I will see you next week with another video about the Gateway API in Kubernetes.